This presentation, we will explore the concepts of railway-oriented programming and implementing it using functional DDD library. We can also think of railway-oriented programming as a way of chaining methods. We will discuss the principles, benefits, and practical applications of ROP along with an overview of functional DDD library and its key features. We will begin with an introduction to railway-oriented programming, cover its core concepts and advantages. Next, we will delve into the functional DDD library, highlighting its features and components. Following that, we will discuss how to implement ROP using functional DDD with practical examples and conclude with best practices and advanced techniques. Railway-oriented programming is a paradigm that emphasizes the use of functions to handle data flow and errors distinctively. It visualizes the computation as a railway track where different paths represent successful and error outcomes. At its core, ROP separates the success path from the error path, allowing for cleaner and more maintainable code. Functions are composed in a way that errors can be handled at any point without interrupting the flow of the program. Some of the benefits of ROP include improved code readability, easier error management, and enhanced composability of functions. These functions lead to more robust applications that are easier to debug and maintain. Functional DDD is a library designed to facilitate the implementation of domain-driven design principles using functional programming concepts. It provides tools and constructs to effectively apply railway-oriented programming. Functional DDD aims to bring functional programming paradigm and domain-driven design to create powerful and maintainable application. It simplifies the integration of ROP into projects. The key features of functional DDD includes built-in support for railway-oriented programming and domain-driven design. Components with the library facilitate clean data transformation and functional composition. In this section, we'll explore how to set up functional DDD environment and start implementing railway-oriented programming with practical examples to showcase its capabilities. To get started, you will need to install functional DDD library and configure your C# development environment. Functional DDD offers a variety of constructs and syntax to facilitate ROP. Understand the basic constructs is crucial for successfully implementing ROP in your project. The result object, it's the one that has the success and error values. Combine lets you combine multiple results. So if one of the results is in a failed state, the entire collection is in a failed state. Ensure validates or executes a given predicate. Bind is called to transform one successful result to another. Tap is called to take an action of a result in a success state. There is no return value expected for a tap. And finally, the result object is unwrapped to its value and error paths. This guide will walk you through the process of implementing railway-oriented programming using functional DDD step by step, ensuring clarity and understanding at each stage of the development. Now let's delve into some practical examples that illustrate the application of railway-oriented programming using functional DDD in scenarios showcasing its power and flexibility. In this example, we will explore how functional DDD simplifies error handling in a typical application scenario. This example will demonstrate the clear separation of success and error paths. So let's look at a validation example. Here, we are creating an email address, first name and last name, and there are specific rules for creating these value objects. And if they are not in the correct format, it'll fail and it'll return a validation failure. So the result from these three function calls are combined into one result. So in this scenario, all the values are valid. So it'll combine these three results. And the fourth one here is just checking for the updated time. And this predicate gets executed. And if it is false, then it'll add this validation failure. Otherwise, it'll keep going. Finally, we have the bind command, which is on the success track. So if all the four things above succeed, then the combined result will be on the success track, which will make it enter the bind path here. And it'll provide us with this email, first name, last name. And in this scenario, we're just combining them into a string and checking. And this should succeed. In case of a failure, where we have another test case here, where the last name is an empty string. Empty string is not allowed for names. And also the date is incorrect. So the created date is now, but updated is in the past. So this is also not allowed. Now, exact same code, but when we execute this, we do not expect the bind to get executed because bind is on a success track. And if it enters there, we're going to throw. It shouldn't happen. We expect this to fail. So once this combine is done, we'll have a result associated here, which should be in a fail state. So that would be true. And it will have these three errors in it. And this is what combine has done. So it took the email address, which has space in it. So that's false. And then we have last name that cannot be empty. And then there is this date that is also incorrect. And that is how this combine works. So this is part of the unit test. So you could try it out as validation examples, and that's where it is located. Now, if we use the same code in Web API, then this is how that would look. So let's look at the user route. It's pretty much the similar code. When a user tries to register, we check if the first name, last name, email are correct. And if it's true, we will create the user object. So let's see this let's see this running. If we come here and I'm going to run this where all the values are valid. So if I send this, it should work. And we get back OK from the server and everything is good. On the other hand, this request here has a bad email address, has got bad last name. So we expect this to fail with a bad request, and it'll tell what are the reasons for failure. And the reason is last name. These two things are incorrect. So this is how your web APIs could look like. Here, we look at a sample code flow that demonstrates how to leverage Railway-oriented programming principles in an async coding mode. So here we have these functions that are async in nature. So finding customer returns a customer, it returns a task. So when that's in those scenarios, we will use the async equivalence when you're calling the functional DDD methods. And they have overloads that take care of async versus non-async. For example, here we have in sync function, and then we have an async function, which just wraps the code in a task. And even if I change the code to async and run these test cases, they will still all just work fine. It'll combine file because they have overloads that either takes in an async function or a sync function and does what is necessary. Right? So we have those things passing. So this is in the sample, we get a customer by ID, and in real scenario, they'll probably have to go hit some storage, so it'll be asynchronous. And that function, if it returns a null, then it will convert to a not found error saying customer ID of so-and-so was not found. If it did return a record, the next thing is running this ensure function to see if this specific customer can be promoted. If it's already at max, it'll just say that's not possible. If not, it calls promote. Promote doesn't return anything, which is why the tap method is used here. Once that is done, we call, it'll go into the bind function, which sends the notification. And then finally, code unwraps the result object. In one scenario, it returns OK. And if it failed, it returns failure, which is checked here. Let's look at primitive obsession avoiding sample that I have covered in greater detail in another video. In the previous samples, we saw that we have this type defined for first name, last name, and email. And this is avoiding primitive obsession. And there is this common value object class library that I provide, which makes some of these easier. It's got a few functions built in, like email address, and then we have required a string or a GUID. So if we look at the definition for if you wanted a strongly typed first name or last name, then from your code point of view, all you have to do is say required string and use this, include this common value object library. The code generator will find this and generate the required code backing this up, which is the try create method, and check if this string is empty or null. And the benefit of having these strongly typed items are that when you have values coming in here, they are actually strongly typed. For example, if I change the order, it will not compile because now the parameter is not correct. So it gives you this error that it cannot convert last name to first name. So this is one of the advantages of getting a type safety by not just using strings and ints everywhere. If you wrap it up to what it means to the domain, first it makes it easier to understand over the long run and maintenance. Initially, of course, it's more work. You have to create these types. Over the long run, they are easier to read, and you cannot accidentally pass the wrong type to different parts of the code. Here we will see how functional DDD helps in creating immutable value objects and aggregates. So in scenarios where you have a value object that just has a single value, you can derive your class of scalar value object. And the base class will take care of implementing the equality components to compare it against this one value. In case you need to override the way it functions, for example, in case of money, you just want the value to be just last two values to be rounded up, then you can still override it and provide it how you want these value objects compared, so that when you compare it to money, it will execute this piece of code. Now, in scenarios where you have value object that have multiple values, like an address, then derive it off from value object, provide your properties, and you need to tell the value object what are the two fields that you would like to compare. And the reason to having explicitly mentioning this is sometimes you may end up having additional properties. Like, for example, let's say in money you had a serial number, or when it comes to the equality comparison, the serial number doesn't matter. So this was a way to give that control where you can decide how the comparison of two value objects should happen. And even if you use derived methods where we have to add something additional, then make sure to call the base class and return all the properties there and the new properties so that they all get compared. So this is examples for value objects. And in a value object, two value objects are considered equal only when all properties are equal. And that's what this basically does. When it comes to an aggregate, the requirement is only that the ID needs to be the same. So in this example, we have two users where they are the exact same ID, but the rest of the values are different. If you run this test, it'll return true. So be aware of this when you write unit tests. When you're checking if you have persisted something to the storage layer and read from it, if you just do should be equal, it's just going to compare these two values, and maybe the rest of the values are not even serialized correctly, or you did not store it. So convert it to some POCO object before comparing all the properties. You got to just be aware of the fact that in an aggregate, for equality comparison, only the ID needs to be the same. And here's another example where the ID is different, but all the values are same, but it will not be considered equal. And that's the main thing to be aware of here. And if you go to the definition, the user object is derived from aggregate, and it's saying the ID type is string because ID is a mandatory column. All the additional properties you can add. And when you create this object, the base class will require ID passed to it. And so the base can take care of your equality comparison. In our final section, we will discuss best practices and advanced techniques for optimizing the use of functional DDD and Railview-oriented programming in your projects. To achieve optimal performance and efficiency, it is important to consider best practices in your function design and data handling when using functional DDD with ROP. Do not force ROP everywhere. Use it only in simple scenarios where it enhances readability. Be aware of closures, and poor design can result in memory allocations by closure. So when it comes to tracing, there are two functions that are available. If you add ROP instrumentation, then all the methods like tap, bind will get logged, and that will generate a lot of traffic. So you probably don't want to use this often. And then common value object instrumentation, if you add this, then whenever you're creating the objects that are required string, required good, or email address, that will provide success or failure for those creations and doesn't create a lot of volume. And you could try these styles for your types too. So let's just run this and see how traces look like. Aspire from .NET is a great place to see these things. If you run Aspire, we can view traces right here. So let's take a look at a sample code. So I added the common value type here and let the code run. The code is very similar to what we had before. There is the first name, last name, email addresses that we create. So when you execute this, so here everything is a success. So we should see OK for all these types that are created. So there's the post traced. And we got last name, first name, email address. They were all created and they returned successfully. Now let's go create a failure. So here's a bad request where email address and last name are bad. So we send it. We get those two errors back. And first name succeeded. We can see last name and email address. So this is a tracing functionality that is there in this particular library that you can also leverage if you want. In conclusion, Railview-oriented programming uses functional DDD library, presents a powerful approach to building clean, maintainable, and resilient applications. By adopting these principles and practices, developers can greatly improve their code quality and application design.